So as we head into the examples, I'm going to talk about two or three more concepts that are going to be very useful. Now, when a question asks you to find the probability of A or B occurring, the probability of A or B occurring is the same as the probability of A union B. Then a question can also ask you what's the probability of A or B occurring but not both. Now, such a question means the probability of A only plus the probability of B only. This is what this question requires of you. So these are the two concepts. Then now, another concept I want to talk about is the concept of cards. So according to the question and according to probability, what we talk about when we say cards, it's a pack has 52 cards. So this is the assumption except otherwise. And now in this pack of 52 playing cards, to make it simple for maybe people who don't play cards, or how we arrange these cards, the cards start from A, then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, then we get a J, a Q, which is for a queen, then a K for a king. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the only digits you're going to find on any card. There are no other digits you'll find. Now, but these cards further, in every pack, we have four different, four iterations. We are going to have a card. So we are going to have the hearts. Then we have an ace, which is called mutima by some people. Then we have a flower. This is mutima. This is a chitiyo. This is a spade. Then this is a heart. This is a flower. Then we have a diamond. So these are the four cards that are found in our pack. The four colors, four colors. Now this happens 4 times. So we have an A from each of these. We have an A that is hearts. We have an A that is flower. We have an A that is a spade. We have an A that is a diamond. So 13 here, 13 cards here, 13 cards here, and 13 cards here. These are 52 cards. Yes. Now, also another thing you have to note is that when a question asks you, what's the probability of us to get an A? Yeah, in these cards to pick out an A. You should know that there are 4 A's. There's an A from each of these. So the probability of picking an A out of these 52 cards. Remember, we said the probability is equal to the desired chance out of the total number of chances. So in this case, what is the desired chance? The chance of picking an A, letter A, on any card, it's 4 out of 52. Same thing, probability of picking a 7, for example. There are 4 sevens in each color. Probability of picking a 7 is equal to 4 out of 52. Another thing, an assumption that is made in these cards is that there are no jokers. That is why for people who play cards know that sometimes there are 54 cards. But in these questions, except a question specifies, but these questions usually we consider whether the question has, if the question does not specify, it means they are considering 52, that is the standard, except where they talk about that there are 54, meaning they're including the jokers. Now, another thing, the probability of picking a diamond. I told you there are 13 diamonds. Each of these, each of these numbers exists in the diamond. Each of these numbers exists in the flower. So the probability of picking a diamond, there are 13 diamond cards, 13 out of 52. Yes, so this is a concept of cards. We are going to talk about it further when we find an example. Now, another thing, when I say X, yes, let me give an example. What can I say? For example, let's say you're given a question and they are saying the probability of X occurring is twice. X occurring is twice as likely. Let me see. X is twice as likely to occur as Y. Now, when you get any of these questions, it's mostly the English that takes the students off. So what is the trick? You should realize that when you read this question, X is twice as likely to occur as Y. When you read this question, it means that X has more chances of occurring because the question has said X is twice as likely to occur, meaning the probabilities of X occurring are more. Now, after understanding that, you now come and say what's the probability of X occurring, what's the probability of Y occurring. In most of these questions, we relate the lower one. So in this case, the lower one is Y, and I've told you how have we obtained that by the language. X is twice as likely to occur. When you listen to this, X is twice as likely to occur. X is twice as likely to occur, meaning the probability of X occurring is more. So we look for the lower one, and that's what we let. So we let the probability of Y be maybe P. Then now this one is 2P. Yes, so now if you've gotten that, then now let us do some examples and see how to go. Now see this for the first example, we have the chance of so which example should we start with? I think we're going to start with this. A pen is drawn at random from a box containing 5 red, 3 blue, and 7 green pens. So we have a box, it has 5 red pens, it has 3 blue pens, and it has 7 green pens. So what's the probability of that a pen drawn is red? So here what is the total? The total is 5 plus 3 plus 7, and this is equal to 5 plus 3, that is 10. No, sorry, 7 plus 3 is 10, so this is 15. Probability of red occurring is 5 out of 15. So we can reduce this to a third. Probability of not red, that is a red complement. Remember we said when we get any two events, probability of red plus the probability of red complement will always be equal to 1. So in this case, we can just say this as 1 minus the probability of red. Probability of red is equal to 1 minus a third, which is equal to 2/3. That's the probability of red not occurring. So this is the answer to Roman 1, this is the answer to Roman 2. Let us go to the next number, and it's about a card is drawn at random. A card is drawn at random from a pack of 52 playing cards. Now this question even helped us and specified, but some questions usually don't even specify the number of cards. Find the probability that the card drawn is a 7. So remember what we talked about, that any card, any pack of playing cards has numbers ranging from A, 2, 3, 4, 5, 6, 7, 8, 9, 10, a J, a Q, and a K. Now, what the misconception which learners usually get is that you cannot hear there is no 1 in the cards. The A is representing the 1. Now, when I ask you the probability of drawing a 7, remember I told you this exists 4 times. Let me now, to make it seem, this exists in the heart. These 13 colors are still found in the diamond. These 13 colors are found in the flower. These 13 colors are found in the spade, in the ace. Now, the probability of getting a 7. So here there are 4 sevens. I don't know if it's making sense. The probability of getting a 7 therefore is equal to 4 out of 52. Should make sense because I've explained to you that they are what? There are 4 sevens. There's a 7 of diamond, 7 of flower, 7 of spade, 7 of hearts. So this is 1 out of 13. When you reduce it further, 1 out of 13 is the probability of getting a 7. Probability of not getting a 7 is 7 complement, which is equal to 1 minus the probability of a 7. So this is equal to 1 minus the probability of minus 1 out of 13, which is equal to 12 out of 13. Then the third Roman numeral says the probability of a 7 or a diamond. Now, I told you that when the question says the probability of a 7 or a diamond, it's the same as saying probability of 7 union diamond. And from the formulas we used, we say the probability of 7 union D is equal to the probability of 7 plus the probability of a diamond minus the probability of a 7 intersection a diamond. So now here we have the probability of a 7, but we don't have the probability of a diamond. So if we can come here on our side, we say what's the probability of getting a diamond. There are 13 colors there are 13 cards of each color. 13 of spade, meaning the probability of getting a diamond, there are 13 cards there, we have an A of a diamond like up to a K. So there are 13 diamonds out of 52. So in this case, it's a probability of 7, which we got up here as 1 out of 13, plus the probability of a diamond, which I've gotten here as 13 out of 52. Now here, I'm going to let you think about what's the probability of getting a 7 intersection of diamond. I'm going to give you 2 seconds to think about it. Okay. Now, I don't know what you thought it is, but note, I've told you each of these colors exists, each of these cards exists once. It exists once for each. So the probability, the 7 in diamonds is only 1. The 7 in diamond is only 1. You cannot find 2. But there are 13 colors of diamond. There are 13 cards of diamond, each of them having a different number. So now here we have 1 out of 52. So you put this into your calculator and you'll be able to find the probability of getting 7 or a diamond. So I think we can now go to our next example. A fair die is thrown. Find the probability that the score is a multiple of 3, that it's an odd or a prime number, or that it's an even number, or a number greater than 4. Now for this case, when a question says that a fair die is thrown, it means that for this die, the probability, remember, a die is something like this. Yeah, it's something like this that has dots. This one 3, so there are 6 sides, 6 faces. So the probability of getting 1 in a fair die is 1 out of 6. Probability of getting a 2 is 1 out of 6. Probability of getting a 3 is 1 out of 6. Probability of getting a 4 is 1 out of 6. Probability of getting a 5 is 1 out of 6. Probability of getting a 6 is 1 out of 6. That is what it means to be a fair die. Like, all these things have been fairly distributed. That is the meaning in question when they say a fair die. Now, when a die, if a question says the die is biased, or some questions can even call it an unfair die. Now, in that case, that what the guy is trying to tell you, that it is no longer the same. That some things are being favored more than others. So we are going to see how. And also, you should note that now, when we have a biased die, the total number of events is equal to everything here. Remember, I said when we're dealing with a Venn diagram of 2, we have something like this. This is A and B. So we have probability of A plus B is 1. And in that case, it's 2. But here, for this case, the probability of 1 plus probability of getting a 2 plus 1 of getting a 3 plus 1 of getting a 4 plus the one of getting a 5 plus the one of getting a 6, all of these should be equal to 1. That is the case. These are all the possible events. Now the question says what's the probability that the score is a multiple of 3. So you now have to understand understand what are the multiples of 3. So let's do here set 3, we have 6, we have 9, and then it can go on. But now for this case, we only have 2 things here that are represented. Yes, the multiples of 3. But however, our sample space, like the possible outcomes, is 1, 2, 3. You can get a 4, you can get a 5, you can get a 6. So it ends here. This is our sample space. So probability of getting a multiple of 3. I've told you the probability of, in a fair die, each of these is a 6th. So I just add a 6. I get 2 out of 6, which is the same as a third. That's the probability of getting a multiple of 3. Now the probability of getting an odd or prime number. I told you when the question says O, it's union, so odd or prime. So here you have to first come and get from our formula, this is probability of O plus probability of P minus the probability of O intersection P. So now in this case, you come here and say, what's the probability of getting an odd number? So here by our side, what are the odd numbers? Here we have 1, we have 3, we have 5. Probability of getting an odd number is the same as saying a third for 1, then a third for 3, then a third for this is 1 out of 6. 6. So here we have 3 out of 6, which is a half. That's the probability of getting an odd number. Then the probability of getting a prime number. What are the prime numbers we know that we have in this case? The prime numbers that we have 2, this, we have 3, we have 5. Those are the prime numbers we have in this case. So meaning probability of getting a prime number, we have to add a 6 for 2, a 6, the probability over 3, a 6, the probability over 5. Then here we have 3 out of 6, which is equal to a half. So we now come and continue with our question. Probability of odd union prime is equal to probability of an odd number, which is probability of getting an odd number, which is equal to a half, plus probability of getting a prime number, which is equal to a half, minus the probability of getting odd intersection prime. And also this one we had not worked it out on the side. So let's come here and say probability of odd intersection prime. What is it? We have 3 and 5. These are the two which intersect. So we shall say probability over 3 is a 6, plus a probability over 5, which is a 6. So here we end up with 2 out of 6, which can be written as a third. This is here we are getting the odd intersection prime, just that we can substitute it into this formula. So here we have minus a third. The probability of O union P is going to be equal to 1 minus a third, which is going to give us the final answer as 2 out of 3. And you'll have solved the question. Now, before we go to this second part, it says probability uneven or a number greater than 4. So uneven or a number greater than 4. Now another thing you have to note in probability is that when that there's a difference between greater and greater or equal to. So when I said greater than 4, it means, let me draw for you a number line here. This is something like this. This is maybe 0, 1, 2, 3, 4, 5, 6. When I say greater than 4, it means this. 4 is not inclusive, but when I say greater or equal to 4, it means 4 is inclusive, meaning for this starts from 5, 6, and on. But for this it would be 4, 5, 6, and going on. So here we say probability of even or, I told you that means union, even or a number greater than 4. So let's first come and find the probability of getting an even number. So we write our sample space 1, 2, 3, 4, 5, 6. The probability of getting an even number would be the same as which we have even numbers 2, we have 4, we have 6. Probability of getting a 2 plus the probability of getting a 4 plus the probability of getting a 6. So this is 1 out of 6 plus 1. Remember, this is a fair die plus 1 out of 6. This is equal to 3 out of 6, which is equal to a half. So probability of getting an even number is equal to a half. So now we come and find out how about the probability of getting a number greater than 4. So from our sample space here, the numbers greater than 4 are 5 and 6. So here we have 5 and 6. So probability of getting a 5 and probability of getting a 6. Remember I told you that when the question says greater than 4, 4 is not inclusive in that case. Probability are greater than 4. Here we have a probability of getting a 5. It is 1 out of 6, since this is a fair die. So here we get 2 out of 6, which is equal to a third. Probability of getting a number greater than 4 is equal to a third. So how about let's also find the probability of getting an intersection, even intersection, a number greater than 4. So in this case, the only number intersection we have is 6. So probability of getting a 6, which is equal to 1 out of 6. So we can now come and substitute in our formula that says probability of getting this union, a number greater than 4, will be equal to the probability of getting an E plus a probability of getting a number greater than 4 minus a probability of getting an even number intersection the probability of getting a number greater than 4. So here we have what is the probability of getting an even number from here, it's here, a half. Probability of getting a number greater than 4 is a third from our calculation, minus the probability of getting an even number intersection a number greater than 4, which is 1 out of 6 minus 1 out of 6. And you can now put this into your calculator, and I think you're going to get the answer as 2 out of 3. Yes, so now we have solved 2 examples. We are going to do a few more examples, then I can let you guys do the exercise. In case you have not understood anything, you can let me know through the comments, and I'll be glad to get back to you with the solution to the questions. Yes, thank you.